Okay. Good morning. Dear President of IUSS, dear Laura, dear all commission chairs, chairs of different commissions, but I think I just want to greet everybody together, dear colleagues. It's a very big pleasure for me to give the keynote presentation, and generally we are very nervous when we do this, and for me it's even more being nervous because I think we were waiting for this Congress so long. And I personally just finished my COVID before I came, so I hope I will not give you a disappointment. I got 1 hour in the program. It's about time to finish if you look at your clock, so we will see how I can manage the time. I was introduced. I'm Erika Michéli. I am a professor and head of soil science and actually my university just changed name. We are no longer Szent István University. We are the Hungarian University of Agriculture and Life Sciences, which is an integrated big university in Hungary. At the same time, I'm chairing Division 1, and I used to be the chair of WRB before Peter. So that's me. The Congress was introduced by all the speakers. And I think this is perhaps in the past 4 years since the last Congress, or more than that, I think this is perhaps the biggest event during this very bad period for the whole world. I think many people explained, I don't have to repeat. Curtis told that we did not expect what was going on. But I think all the investments what the organizing committee did, like those who were on the field trip, we know how much time it took just to go around. They had to go there to work. I don't know how many times. So I think it was a tremendous effort what these people did for us. So a very big thank you to the organizers. And not everybody is on this picture because there are people who did not come for the field trip. But a very big thank you to all the organizers. So just thank you, thank you, thank you. And the name of the Congress did not include, when we got all the materials, that it's the 6th. But I'm very proud to tell that the first soil classification conference was held in Hungary, actually more than 20 years ago. Then we had it in Russia, in Chile, in the US, then in South Africa, and now we are in Mexico. So I think we can celebrate 20 years of soil classification meetings. So it's great. I will turn back to that. And just for those who were not there, I think it's only Peter and me who were in that Congress. I don't think anybody else in this room attended the Congress, but this was the first group that decided that we have to continue with this kind of meetings because we found that there is so much to study in classification. And the title of the presentation is The Major Steps in Soil Classification. And here is the content, what I am going to talk about. And 100% sure I will have my personal professional bias. There might be other opinions about what are the major steps in soil classification. And most probably I will also have my national pride. But here you see I will talk about the differences that there were there from the very beginning, because when we are talking about classification, we are talking about differences. I will talk about the genetic paradigm, the profile, the depth function, the diagnostic approach, the qualifiers, new sensors that are helping our work, and pedometrics, and the new way to look at taxonomic relationships between soils. So the beginning. The differences were very important at the very beginning. So the Olduvai Gorge, which we consider the cradle of mankind, which is in the Great Rift Valley, was a very special place. The living floor with high organic carbon and with the right amount of moisture was just a place where human being could start. And we have actually the earliest evidence of existence of human ancestors. But soil was very important. And later, when more developed civilizations developed, they were also very much tied to soil. If you think about just the fertile river plains like Egypt, the Indus Valley, Mesopotamia, or China, those were very fertile lands. But not only the development and the blossom, but often also the decline of those civilizations or societies were very much related to soil, especially to not good care of the soil. So that's another message. It's not only classification, but also maintaining good soil. And later, when agriculture became very, not intensive, but also when agricultural practices started, the first kind of classifications were related mainly to the use of soil and mainly to management. So the properties that were observed and used to make differences between soils were related to tillage, mostly to heavy or light texture or stoniness, and also to properties that were very easy to sense, like color. And also the names were what people used first were stony soil, sandy soil, clay soil, or red soil or black soil. The first scientific classifications developed in the middle of the 19th century, and I think all of we know this, but I thought we have to spend a little bit of time with Dokuchayev. So this young guy, Vasily Dokuchayev, had a very deep interest in nature, in agriculture, and in soil. And he started to, to make differences between soils, but it's very important that during the period when he was active, taxation was very important, and people wanted to know why one soil is more fertile than the other one. So Dokuchayev and his colleagues were the first people who found out why some soils, and especially the Chernozems, the Chernozem, were more fertile than other soil, and they developed the soil forming formula, and these are Dokuchayev's words. The formula clearly shows the conditions of formation, identity, and possible variations in soil, depending on changes in soil forming factors multiplies. And his formula, the soil forming formula, is still our paradigm. And why we spend a little bit of more time with Dokuchayev, it is that we still believe in his principles. And also last year was the 175th anniversary of Dokuchayev's birth. And if you are not familiar with this paper, I suggest that you read. It's fascinating. It is telling about how Dokuchayev developed his interest and what periods of his research were existing until he died. But his major contributions, it was the very extensive field work. So he proved first that we really need a lot of field work to understand what is going on in soil, why they are different. He also started with the detailed description, introducing the horizons and the designations, and of course the classification. He was the first who was really identifying zones. And of course, his publications and his work on popularization of soil science were very important. In these pictures, you can see his samples. He gathered huge amount of samples from different parts of Russia and elsewhere, but not very much. Here you can see the sketch map of the Chernozem zone of the European Russia. And those who did not know, he also prepared a sketch map of soil zones of the Northern Hemisphere. And of course, everybody knows about his book, the Russian Chernozem, and that was his PhD work, actually. And when he was defending his PhD, it was not an easy job. It took almost a day. Mendeleev was the chair of the committee, and he was really challenged. But finally, after a long day, his ideas about soil formation were accepted. Of course, he was not alone. He had a great group of people, co-workers and famous students like Sibirchev and Glenka. And I put Mendeleev there, who was the senior person in his department. The profile. I think it is very important that we work in the soil profile. This will come back at other places in my talk. But Dokuchayev and his students were the first who were really introducing the genetic horizons, the A, the B, and the C, but we have to do that others were using, but not in such a systematic way as Dokuchayev and his students. So these principles, what they put down is still valid. We are still discussing and refining, but they put down the basics for us that we are still working on it. You can see that even Darwin was drawing profiles, and later many scientists are preparing nice profiles, describing profiles, and some of them are coming up with very artistic way, like Kubiena with profiles. And this is a good time for me to acknowledge the beautiful cover page of our field guide, very artistic, but sometimes we don't need an extra touch of human art to have some very artistic profiles. So this was one of the profiles we saw. I think it's beautiful. It's almost artistic. Okay, so Dokuchayev did most of his work in Russian, I mean, the publications. And the journal that they had, the Почвоведение, actually it's soil science, so that was mostly where he published his material. But his students, Glinka and Sibichev, mostly Glinka to the west, they were bringing the Dokuchayev ideas to many countries, and translation to German, French, and English just came later. And actually the US invested a lot of money, and also Israel invested a lot of money to translate. So today, most of the work is available. But, and here comes my national pride, one of the first places on international level where the Dokuchayev principles were introduced was the first international meeting in agrogeology held in Budapest in 1909. And the people who participated, it was the huge guy, it's the German Raman, you know the Raman brown forest soil, named after himself, and Glinka was there. These people gathered together. Actually, it took 3 months to organize the meeting, and it was just normal mail. But they had 5 days of conference, and they have, I don't remember how many days of field trip. They were traveling by train and horse carriage, but there was a lot of time to discuss. So they spent huge amount of, very little time with organization, through normal mail, but a lot of time of meetings and talkings. And fortunately, the organizers, the Hungarian committee that organized, recorded every single word what was said during the conference. So that gave us an opportunity in 2009, first of all, to celebrate the meeting in 1909. We called it Bridging the Century. And we had the chance to go to the field. Actually, we were playing Raman and Glinka. Those two guys are Raman and Glinka. And since we had all the words recorded, we could go to the field, go to the same profile, and have the same discussion what they did. And Raman, who introduced the Raman brown earth, he was calling these soils everywhere, even where there were great clay accumulation horizons. And this profile that you see here, actually it's a historical profile because Raman considered it as a brown earth. Actually, it was a beautiful clay accumulation soil, and they had a heated discussion. We have the records, so we played this very heated discussion where Raman said, yes, it is a Raman brown earth. Actually, Glinka had to come back to Hungary later, and he proved that there was a beautiful clay accumulation. But the participants from the US, from Romania, from Bulgaria, and from the neighboring countries got really confused. So for many years, in the classification of forest soils, there was a confusion because Raman called the beautiful clay accumulation soil as a brown earth. And actually later, Guy Smith and Tavernier published a very long paper about this, and they sorted out what was wrong at that discussion. And anyway, it was a long side talk. What did they found out during that meeting? It was called agrogeology, but actually it was about soil. But they declared that soil science has to be a separate science. It needs its own common terminology because they were using different terminologies, and also methodology for observing, investigating, classifying, and mapping soils. And what we found 100 years after, that we still need it. So when we had the meeting, we just concluded that 100 years after, we still need a common methodology, common language, and common ways to communicate, classifying and communicate soils. Actually, this was the time when the universal soil classification idea was born. Okay, now going back to the Dokuchayev ideas, there were several meetings, and it's not a complete overview of all the important steps. There were meetings in Poland, there were the world shows where people could present what they did. But one of the biggest events where the Dokuchayev formula was really becoming more known to the world was the first International Congress of Soil Science in Washington in 1927. So many people got familiar with it. And Hans Jenny expanded, he made it more numerical, and he also made some very important statements that it's very nice that we have the horizons, but most of the properties have their own depth function, the depth distribution, but we are coming up with horizons. And this designating the horizons is always very much left for the individual judgment. So it's nice that we have the profile, it's nice that we are having the boundaries, but there are no real boundaries, there is a depth function. Actually, the next very big step was when Guy Smith introduced the diagnostic approach. It did not solve the continuous depth function question, but it solved a lot of the subjectivity. When he gave his talk in Ghent in 1952, he was explaining that in the diagnostic approach, genesis does not appear in the taxa, but it is behind. And actually, it was not very welcome. So most of the people who attended the meeting were not very happy, because we are so happy, and we were so happy to discuss genesis and how it formed and so forth. But with the diagnostic approach, these soil-forming factors and soil-forming processes are resulting in certain horizons, in certain materials, in certain properties. And if we define them and we define a threshold value of the development, then we can consider them diagnostic, and much less decision is left for the individual judgment. I think it was one of the real big steps in soil classification. So in the diagnostic approach, horizons, properties, materials, these are elements, very essential blocks to support the objective soil classification. They are established as set of properties for specific intervals of the soil body. So instead of just having properties, it's set and it refers to a certain part of the soil body. And also, they carry very important information themselves. And that's very important, regardless to which class the certain diagnostic belongs to. So it is supporting not only classification, but it provides a diagnosis for the soil for management and conservation purposes. If we have the diagnostics, and then if we have the presence or the coexistence of some diagnostics, we can also judge capability to supply soil functions. So we see many works that are dealing with soil function, and fortunately more and more approach is related to the diagnostics. There is another very important thing, that when we are mapping, most of the time the map unit is a class, a soil type, a reference group, or a lower unit. And often the spatial extent of the diagnostics are not the same. Just for you to understand, here we have the map based on the European soil database 1 to 1 million. On the left, you see the reference groups belonging to the Chernozems, the Castanozems, and the Feozem as dominant soils, and they are covering together 4.7% of the area. And that time, actually, when it was prepared, the Chenyic horizon was not present. So all of them had mollic horizons. But on the right side, you see all the soils that have the mollic horizon. So the mollic horizon has a different extent, much bigger. And it's very important if a soil is not belonging to those groups, but still has a mollic horizon. It's a very important piece of information related to soil function, related to carbon sequestration, related to preserve carbon and so forth. It's another example. So the glacial soils occupy about 5.3% of the territory of Eurasia, actually. But on the right side, you see the soils that are having the glacial properties. It's very important that we have the spatial extent, so the diagnostic elements are really very important elements to understand some features. But unfortunately, we don't have the same definition for the diagnostics. If we could have the same definition, then correlation and compilation of global maps would be much easier. And this is very well exemplified in the case of the Atlas of the Northern Circumpolar Region. So when the Atlas was compiled, national data were used and some international data was used. So soil taxonomy considers jelly soil actually on the after the histosol, right? Or above? Above. So jelly, a soil, if it has the evidences of a cryoc horizon, or I don't have the exact definition, it's a jelly soil. In Russia, if a soil has all this, but there is more soil development, then higher in the priority is given to the developed horizon, so it's a cryozone. In the WRB, the cryosols are coming after the histosols. So the spatial distribution of the cold soils, if we consider these three very important systems, is absolutely different. It's very embarrassing. If we want to communicate information on a global level, where are the cold soils? Then we say, it depends if we use whichever system. But if we use the diagnostics of where are the cryoc horizons, and if those are at least defined similarly, I think we would have a much better situation. So I suggest that we keep it in mind not to go too far from each other. This was hierarchy. So these maps are different from each other because the priorities of the systems are different. So the hierarchy is sometimes causing a lot of problem in correlation, but not only in correlation, because many of the soils carry the properties of many soil types, and the key takes care. So that is taking care of the priority within the system. But often in the hierarchic system, some properties may not be acknowledged. And we experienced it, sorry, Curtis, I'm always coming up with the gypsy soils. So sometimes if you have a lot of gypsum in soil taxonomy in the hierarchic system, gypsum is not really acknowledged. So I think the next very big step was dissolving the hierarchy and introducing the qualifiers. I think in soil classification, qualifiers are a really big step. Because the established properties can be acknowledged, no matter on what level, because we have the hierarchy only on the first level, we have the key, and after that, every established diagnostic feature can be acknowledged in the classification. Of course, we are not using it in oral communication, I mean, not all of them, and recording all of them, I think it's very important in different applications, but later I will say, but we have to be a little bit more careful with the number of those. Okay. The next, it's not a big step. I think it was not a step forward. I think it was a little bit step backward, that we a little bit complicated the definitions. What you see here is the definition of the mollic epipadan in soil taxonomy. Of course, you don't have to read. This is the skeleton of the definition. And this is occupying 1.5 pages. It has 9 major diagnostic requirements. It has 6 sub-requirements. It has 2 third-level sub-requirements. It includes 10 ors and 10 and. And all this is referring to structure, color, base saturation, organic carbon, and depths. So it's just very difficult to teach and follow up. So actually, it's almost the same in the WRV. Now I'm making a little bit big step. I think one of the next very big step in classification, in describing soils, and of course, since the result is supporting the decisions in soil classification, I think it is the development in observation of the profile and horizons. Oh, sorry, I went the wrong way. So when we are in the profile, generally there are a set of properties that we try to identify, but there are always very big individual differences in the observation, as we experienced on our field trip. Is there a lithological discontinuity? Where is the horizon boundary? Are there hydromorphic features or not? How much? Is the carbonate secondary or not? So these are decisions that need a little bit of support, and we do have a lot of modern tools that we can apply. It's proximal sensing and remote sensing, micromorphology, and digital soil morphometrics. And I don't want to talk about those too much. I think most of you know what proximal sensing means, that we are not in direct, it's not invasive, it's a very close touch with the soil and getting the signal. We can predict the information, but we should never forget that calibration is still absolutely necessary when we are using proximal sensing data. But it helps in the field. Actually, the price of these devices are very different. So when you use an XRF, it's not so cheap, but you can identify differences in the profile, even on the elemental composition. And of course, the interpretation is still very important. And there are some small, less expensive devices that we shared with you in the field. But actually, I want to tell to the colleagues who came to the field trip, I think it was very exciting to try it, but I think we should still take the monthly color chart with us. Not only because it may not detect the right color, but we have to know how that color looks like. So it's just not that it's 10YR 3/2. I think we still have to visualize and know what it means that a mollic horizon generally has that color. So I think it is only an assisting tool, but it's not a tool by itself. Micromorphology, I think we experienced on the field trip how much help micromorphology can be in soil classification. It helps to decide about accumulations of carbonate, accumulations of gypsum, and there is a very big advance in this, in the spatial, the spectral, the radiometric, temporal resolution, and there is a very big increased computational capacity. So these tools are really promising. And it's not really in sequence in time, but I think one of the very big steps in classification is the computer. Most of the classification systems, including soil taxonomy, including WRB, almost all the national classification systems were developed before the computer was available. And it's very interesting that even Guy Smith, in 1968, 1986, before he died, there was this famous Guy Smith interview when people were asking him questions. Why did you decide about this class? Why did you decide about that boundary? Why did you decide about the depths? And he didn't know. He just said that was my best guess, but if someone can come up with something, perhaps a computer, there was no computer at that time, someday when we get enough data stored, perhaps we can come up with relations that would suggest something that no one has thought before. So with our human brain, we have ideas, we have properties, and we compare soils based on those properties, but using our human brain. But the computer, I think, was a very big step, and pedometrics, I think, was a fantastic step in understanding differences in soil. And we know that pedometrics is an application of mathematical and statistical methods in soil studies. So the Universal Soil Classification Working Group that is not as active as it should be, or it's not as commonly working together as it should, but there is a lot of work going on in the background. With these mathematical approaches, we can evaluate the depth functions, we can do similarity, dissimilarity studies, calculating existing taxonomic distances, and we can also define existing soil groups with similar properties in space. I cannot go into very big details, that would make need an entire lecture, but the centroid approach means what we are using in the Universal Soil Classification Working Group, that if you have enough data, you can create some average profiles of the same taxa based on major soil differentiation properties that we base on soil classification on. And actually, these are the data that we mostly use for set depth intervals. And we have a continuous depth function of those properties. So if you create those centroids, you can evaluate the depth function. And here is an example for the mollisol order. So we have the depth function of organic carbon on this figure for the mollisol grade groups. And the one which is the thickest, the brown line, that's the total average of the grade groups. And we can see that we expected anyway that soils with a high amount of sodium, the NATROC walls, are a little bit different. No, that's the other slide, sorry. The red one actually is the haplorandol, the very shallow ones with high organic matter on the top that can sit on hard rock are a little bit different, a little bit outliers. And soil taxonomy doesn't have a leptosol group, so maybe they have to think about to come up with those shallow soils. And the other example is actually now we see still the mollisols, and this is showing the depth function of the exchangeable sodium. So you can see that the NATROC wall is giving a very different figure in the depth function. Of course, we have to look at all the data. These are just all the only examples, but we can have the centroids created by using all the characteristics, and one taxa can have one centroid, and we can compare how close or far they are from each other taxonomically, and we can define it numerically. So don't look at this table in big details. This is just showing that we can come up with numbers that are showing the differences between soils based on those properties, based on set intervals, and we can calculate it, but we can also visualize. On this figure, you can see the taxonomic distances of all the grade groups in soil taxonomy. One color is showing the grade groups in one order, and this is plotted along the first three principal coordinates. And what it shows, the dots of the same colors are the grade groups of one order, showing how far they are from each other based on those properties for the depth intervals. And it would take a long time to really interpret, but if you look at the black dots, those are the vertisols. They are relatively close to each other. If you look at the aridisols, sorry, Curtis again, the aridisols are scattering all the way. So this is showing, this is the first time when based on the computer, based on a huge amount of data, you can calculate those differences that we are trying to make based on our brain. We can also calculate them. But we have to be careful which properties we use, which depths we use, what kind of data you use. So there are also some dangers how we use it. Actually, this was the first step in evaluating the pedometric applications, and first step, and we went further with the working group of universal soil classification. And actually, after this first set based on US and the WISE data was created, we added more data. And on this figure, the black dots are coming from the Australian soil data, showing that the centroids of all the taxa of the Australian classification are not totally covering the space what we had from the US and the VICE data, showing that some of the soils are not exactly belonging to the same kind of soil. So when we are doing these centroids, we need a lot of data. We can define where are existing entities that are the same. I hope you could understand what I was trying to say. And if some of them are matching exactly, that means those are existing soil units. Actually, the next step is that the Brazilian data and the French data was added, and those centroids were added, so we can tell more where are those centroids that are existing. And I think our colleague who was talking about the 20,000 profiles in Mexico, I think that should be added to this study. So the more data is added, the better interpretation we can have. This will be presented in Glasgow by Alex McBratney, so if you have an interest, we can go to deeper discussions. Now, so the major steps, the Dokuchaev formula, obviously, the systematic description of the profile, introducing the diagnostics and the key, introducing the qualifiers, applications of modern observation tools, and application of pedometrics. And this is not the end of my talk yet, sorry. But this is summarizing the major step that I thought are the major steps in soil classification. But I have to go back to 2006. And this is Otto Spargaren. Unfortunately, Otto is not with us anymore. He was a key person in the development of the WRB. And Otto gave a talk. And the title of the talk in Philadelphia was Wittingly Reaching Babel. And this talk was about how great the qualifiers were, but he also expressed his concern. He was worried that the number of qualifiers in 1998 were 121, then it increased in 2006 to 179. Now in the 2015, we have 185. And the specifiers and sub-qualifiers and everything is increasing. So these were his suggestions he made how to eschew Babel in the coming years. And he wrote this in 2006, but he's not with us. Maybe he would have changed his mind a little bit. But I thought we should acknowledge Otto's thoughts. It's the consolidation of the reference groups, critical review of the functionality of the qualifiers. Why we have a qualifier? What is the function of introducing a new qualifier or specifier or whatever? And I don't read the whole thing, but I think I just wanted to give a little thought to that. And these are my suggestions following Otto. So I think we have to be careful not to reach Babel. And just an example, this was our beautiful soil in the Sierra Madre in the pine forest. The final classification, it's a Luvic, Vetric, Vertic, Endocalcic, Phaeozem, Chromic, Catocleic, Epireptic. How in the world we can communicate it to users, other sciences, or to the public? Very difficult. I think we had so much fun. Is it Kato or not Kato? And this group is generally together, but most of the time we talk among ourselves. But it's very important that we somehow communicate it to users. So that's one thing, and I will summarize in a summary slide. The other is why we are doing the soil profile. So we have the soil body concept that said the pedon is the smallest body volume in the landscape that represents a soil pattern. And the profile is a two-dimensional section exposed where we characterize the pedon. If the profile is classified too precisely, it may not represent other pedons of the polypedons. I think it's a danger. If you go maybe 2 meters apart, it is not representing something 2 meters apart. So based on that, careful not to reach Babel. Is that, and these are just not related exactly to the slide before, but I think we found that we still have to harmonize methodology. So we had to adjust methodology. I suggest that we establish a task force within Commission 1.4, dealing with methodology, both field and lab. And also, I suggest that we establish a task force on easy communication of classification information, some simplified names, maybe infographics. So and I'm not saying that we should not be precise. We have to be, but to be able to communicate, we need some simplified versions of our outcomes. Okay, and this is really my last slide. So we are celebrating more than 20 years of these classification conferences. I think we need another 20 years to go, at least. And thank you very much. I don't know if there are questions or we finish, or I don't know what is the procedure.
Let me see if there are some questions on Facebook. Thank you very much for this keynote conference. And I don't know if there is some questions at the streaming, but I don't know if there are some questions in the public, or we can continue with the program. Okay, yeah.
So the numerical statistical approach is being built. Oh, yeah. Thank you. Thank you. Erika, the way you described it, the numerical statistical approach is being built on our current concepts. So the data, whether it's, mollusols or other taxa, in terms of gathering the data is very skewed. It's not random whatsoever. You have these soil scientists with the genesis in their head that will take a representative profile. Okay, so is that a problem, trying to build statistics on something that's built on 100 years of genesis? Should we just start over and base it on random statistics?
Yes, it is a problem. But this is one approach. There are several approaches where they are, when only from raw data, some classes are generated, and then we are comparing the generated classes with existing human-made classes. But this would need an entire big lecture. I'm not the greatest expert, so I think you should come to the meeting of the Universal Soil Classification Working Group, and there are other approaches. But of course, it's very important to test first and not throw away what we have. So that's one way to do it, to test what we have, and the other way is to generate absolutely new classes. But there are some very extreme fanatic ways that people are coming up, not with names, but numbers, and that would be very scary for a group that is doing WRV in the field with all the specifiers and so forth. So I think for the time being, communication, I think, also has to be gradual to introduce the numerical approaches. There are other approaches, but I didn't talk about those. And yes, that's a problem.
Any other question?
I am coming from Cuba. Excuse me my poor English language. Dr. Michéli, you give us a very good conference. In this conference, there is present the two School of Soil Classification, the Russian, who is the soil forming and process forming of soil formation, and the soil taxonomy, and besides the world reference base. But my country is very, very, very little to apply the world reference base of or the soil taxonomy is very, very hard. In tropical soil, I think it's necessary first make a union between soil factor and process of soil formation with diagnostic and characteristic horizon. We are making that in Cuba. And besides the degree of soil evolution, that in the French soil classification is a very, very good example. For example, from young soil or can be soil to alitic or ferritic soil. There are some degrees. And it takes in account, for example, Stanley Buell gives us the process of formation of vertisoils. In Cuba, we have some step of this formation, so that there are characteristic diagnostic and horizon diagnostic of vertisoil. Each country has its very, very variation of soil properties, and apply the world reference base or soil taxonomy is not easy. So that each country make some apports, I don't know in English, to the soil classification. I think it's very important to take in account two problems: factors and process of soil formation and horizon and characteristics diagnostic. It's very, very important. So we are trying to make this in Cuba, and we are making now a soil taxonomic classification. Thank you.
So thank you for the comment. I guess it's a comment, not a question, so I don't feel I have to answer. Thank you.
Thank you. Thank you very much, Erika Michéli. So we